Section 3.4, truth tables for the conditional and biconditional. Recall the conditional is for the connective if-then with the symbolic form as the arrow with one head, and the biconditional or the connective if and only if, the symbolic form using the arrow with the two heads. The objectives for these sections are to understand the logic behind the definition of the conditional and the biconditional, to construct the truth tables for the conditional and the biconditional statements, and also to determine the true value of the compound statements for a specific case. For the conditional statement or if-then, with the simple statements PQ, we use the notation P then Q. P or the left side, the left expression or the expression on the left of the arrow is called antecedent. The right expression or the right statement of the arrow is called the consequence. When we read it with if P then Q or if antecedent then consequence, the conditional is false only when the antecedent is true and the consequence is false. As you look at the truth table, for the two simple statements PQ, we have four combinations as we set up earlier. The combination of the antecedent true, the consequence false, gonna give the if-then statement or the conditional statement false. Other combinations gonna give the result as a true statement. Examples: construct a truth table for not Q, then not P. The main connective is if then or the conditional statement. The left statement is not Q. The right statement is not P. So in this case, not Q is called the antecedent. And not P is called consequence. To construct the truth table, we start with the first two columns, with the columns for the statements PQ with the four combination. How many columns we have to add? As we analyzed before, we're gonna have to get the column for the not Q, have the column for not P, and then connect these two with the if then or the arrow or with the conditional statement. So we're going to have the last one as not Q, then not P. Therefore, we have to create three more columns. So the first one, which is the antecedent or the statement not Q, based on the Q column, we're going to use the negation of the truth value that we see. For the truth value as a true, not Q gonna be false. For the false gonna be true, the true gonna be false, false gonna be true. Now we got the antecedent done. Okay. Next, not P. From the first column or the column of the P, we're gonna write the negation of each truth value. For the true, the result gonna be false, and then false, and then true, and then true. Based on these two columns, we're going to connect them with the condition statement or the if then. For the if then, only the case that make it false is when the antecedent is true and the consequence is false. Gonna give you false, otherwise the result gonna be true. When you look at the combination like row by row or case by case, false then false, which is not the case of true or false. So then the result gonna be true. The second combination, this is the one that gonna cause the false statement because it's true then false. The result is false. False then true is true. True then true is true. Then we have the truth value for this truth table as a combination of true and false. And we can summarize on the bottom again as this compound statement is not a tautology. Another example, we have the compound statement which has a bracket and have the group inside of the bracket, and the main connective is if then or the conditional statement. So we're gonna construct more columns based on how many columns that we need. First of all, from the bracket, we're gonna have to do from the innermost, which is the P or Q. So I'm gonna make a list on the side here. Since P and Q are have to be there by default because the compound statement based on the two simple statements PQ. We're gonna have like 4 rows no matter what, but how many columns depends on the compound statement that you are working on. So to see how many columns we're gonna need the column for P or Q. Gonna make a list here. P or Q is the innermost, and we're gonna connect the P or Q with the not P. So we're gonna need another column for not P. Connect these two together, which give you the compound statement within the bracket. So next will be P or Q quantity and not P. So 3 columns so far. And we're gonna need to connect whatever the result that we got here with the Q. Q already given as a default. So we're gonna have one more column as the column of the result, which is the column of P or Q and not P in the bracket. If then or the conditional statement with the Q. So therefore we're gonna need 1, 2, 3, 4 more columns as you see on the screen. Based on what we have, the P and Q, the 4 combinations, true, 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 false, false, true, false, false, P or Q, recall the OR. For the OR, only the case that false or false gonna give you false. Otherwise, the truth value gonna be true. So as you see, true or true, gonna give you true. True or false, gonna be true. False or true, gonna be true. False or false, this is the case, it's gonna give you the false statement. And that's the observation for the connective OR. The not P, which is the negation of the P. Whatever you see for the column for the P, we're gonna do the opposite or the opposite truth value. True, true, false, false becomes false, false, true, true. The first and the second part done. Next, we're gonna connect them with the connective AND to complete the compound statement in the bracket. So this time, these 2 columns with the AND, and. For the AND, both of them must be true to get the result true. I'm gonna put a note here. So true and true to be true. I'm wrong here. So true and true, result gonna be true. Otherwise, it's gonna be false. This is OR, this is AND. For the AND, both of them are not true. The result gonna be false. Both of them are not true, gonna be, I said false, but I wrote true. Sorry about that. So this will be false, and this is both of them true. The third case gonna give us true value. And last one back to false because not both are true. Now we get everything on the left side of the expression. And next, we're going to use what we have here with the Q. Okay. For our convenience, you can also create another column just uh, for us to identify in the easier way. If we add another column, it should be the column small one here. This is the column Q. Pretty much you are copying the Q column over just to make it easier when you identify or determine the if-then statement. For the Q, right here, the Q truth value could be true, false, true, false. And we consider if-then. The if-then means, the if-then, I'm going to write it this way. For the if-then, the observation, only the case is the antecedent true, the consequent false, the result going to be false. Otherwise, you're going to get result as a true. For our case, false then true gonna be true. False then false gonna be true. True then true is true. False then false gonna be true. It turns out to be all cases are true. And this case is the case of the tautology. So we put the note on the bottom here. So we can say this compound statement is a tautology. As a summary.